whales worth of garbage that's entering the ocean. And so it collects in these areas called ocean gyres, and everyone here has maybe heard. And so when we think about all this plastic being in the ocean, you think, okay, there's got to be some impacts. And so I'm going to talk to you about some of these impacts. And I think to address probably one of the most common questions that people have is, if we know that fish are eating plastic and I'm eating fish, am I in turn eating plastic? And the answer is very complicated, and we're nowhere near close to answering that question. We're just starting to learn the impacts on animals, let alone humans. So first, the most obvious and often heart-wrenching impacts of plastic pollution in the ocean is entanglement. So this is when these larger pieces of plastic get caught up, animals get caught in it, and often it's due to derelict fishing gear and nets and things like that. And then the more insidious version of impacts in terms of plastic pollution is ingestion, and that's basically when animals are accidentally eating plastics and microplastics. And like the photo up here, so that's a albatross, and it's a pretty famous photo. And so albatross basically feed kind of on the surface of the water, and they end up ingesting a lot of these plastics and sometimes accidentally feeding it to their young. And then, of course, there's many, many species of fish that have been recorded to have microplastics in their guts. And so when we talk about this, that's what we are concerned about. We're concerned about us being at the top of the food chain. We're concerned about these apex predators, this risk of bioaccumulation. So we talk about bioaccumulation in terms of heavy metals and POPs. And so we're wondering, does plastic bioaccumulate up the food chain? And it has recently been recorded that plastic does transfer from species to species. And that's kind of what I'll be looking at since I'm looking at the entire food web. So some of our lab, not our entire lab, but a lot of us are working on this microplastics problem. So although we don't have all the answers for you, we're working really, really hard to find out. And we're looking at many different aspects of it. So I'm looking at the Beluga food web. My colleague Lauren Howell, who's in the room over there, wave. She is looking at zooplankton in the Canadian Arctic. So we know that zooplankton is a very important underlying structure of all the life in the ocean, and she's looking at copepods. I was joking around that it sounds like Cocoa Puffs. She's looking at Cocoa Puffs, ingesting microplastics. And Julie, who's in the audience, wave. She's very shy. She's looking at blue mussels on the coast of BC. So she's looking at the number of microplastics in blue mussels, and if blue mussels are able to actually identify if microplastics are food and essentially spit it out. So that's pretty interesting too. We're also looking at wastewater treatment facilities and how many microplastics are in wastewater and being released and how we can combat that. We're looking at laundry, so we're working with different partners like MEC and Arc'teryx to figure out what fabrics shed the most and how we can reduce that. And then there's my project. So I just started this fall, so I went I'll talk a bit about it. So I went to Tuktoyaktuk in August, and then I hopped on the C3 ship after a couple weeks, and I sailed around Alaska, and I collected more data and things like that. And so I'm just starting to process my samples, and it's really exciting. So basically what I'm looking at is if there are microplastics in ocean sediment and in water samples, specifically in the Beaufort Sea, so that's my study area, is it ending up in the beluga food chain? And so this is a map just to show you of my study area. So you can kind of see the Beaufort Sea right there. And then there's Tuktoyaktuk, which is at the tip of the Northwest Territories. And it's also called Tuk, so I often call it Tuk. And it's a Inuit hamlet. So Inuit is Canadian Western Inuit. And they're a hamlet of hovering around 900, so quite small. And they have a very rich culture of hunting and fishing and gathering berries. And part of these activities, of their hunting activities, is having this annual beluga hunt on an island called Hendrickson Island. And so that's how I'm able to get my samples, my beluga stomachs. I do not go and get the belugas myself. So we have a partnership with the community where they hunt the whales around 15 to 40 each year, and it sustains a lot of families throughout the year. And then they basically provide me with these beluga stomachs and these giant pails, which is pretty neat. And there's a reason why they hunt and fish and gather things, is because not only is it incredibly important to their culture, they've been doing it for generations, and they're used to eating this food and they're very connected to it. But when you look at the price of imported grocery store food, it's absolutely insane. When I went up there, I just couldn't believe it. And I'm never taking food for granted ever again in Vancouver. It's so cheap here. So I don't know if everyone can see the numbers there. So that's a cabbage that is $8 and lemons are $10.30. So, you know, if you're going to go and get a caribou, yes, it could be expensive with gas, but think of how much that feeds your family for how long. And it's part of their culture. And so here's just some photos of those food sources. So the top left photo is raw. So I'm vegetarian, but I stopped being vegetarian when I went to the Arctic because, you know, everyone was very generous with allowing me to try all their cultural foods, and it was a really interesting experience. So the most interesting thing to try was definitely raw caribou, raw frozen caribou. So basically, especially at community events, they cut off pieces and you dip a piece of this frozen raw caribou in salt. And then they eat a lot of different fish. So a lot of these fish I am including in my food web. And then the bottom two photos are muktuk, which is basically beluga blubber. So that's why I see some people getting a little squeamish, but it provides a lot of calories and a lot of nutrients and vitamins and things to them. So, and it sustains a lot of people throughout the year. So that's why it's so incredibly important to monitor these emerging contaminants like microplastics, because anything that potentially threatens the health of these animals threatens their culture and their diet. So these are the animals that I'm looking at. So I'm looking at beluga whales. I have 4 beluga whale stomachs right now, and we'll likely get 4 more. And then I'm looking at saffron cod, Arctic cod, so those guys in the back of the room there. I'm looking at Arctic cisco and flounder. And then I'm also looking at capelin. And I have the number there. So I have 20 of each of those fish. And then the capelin I have as to be determined, because basically I haven't received any capelin samples, but I'm finding capelin inside the stomachs of fish, so it's quite convenient that I can include those in my food web. And I'm really grateful to the community. They're incredibly welcoming, and I formed a really special bond with one young Inuit girl there named Chiquita Grubin. And we put out her family's net, and I was able to get a lot of my sample fish through that. And so it was a really beautiful way of incorporating that traditional way of harvesting while getting the sample species that I need. And she was able to introduce me to a lot of people in the community, and it was a pretty great experience to be able to canoe on the Arctic Ocean to get water and sediment samples. And I also participated in some non-fieldwork things. So this is called a blanket toss. So it's kind of this traditional, I think traditionally they used it as ways for hunters to be able to see across the landscape and spot caribou and whales and things like that. So you're thrown way, way up in the air by the community, and you're supposed to look out and tell them what you see. So they convinced me to do it, and it was slightly frightening. So that's me on the right side there. Okay, so after field work comes lab work, which is sometimes not as exciting, but we generally look like we're out of Breaking Bad. We like bananas, so this is a Tyvek suit. And the reason that we wear this is because, remember what I said about our clothing shedding these tiny, tiny fibers? It's floating around in the air everywhere. And so if we're looking at a sample, if I am dissecting a fish and then digesting that, and then I want to look at it under a microscope, and I'm like, oh, there's a lot of black fibers in this. The ocean is so polluted. And then really I'm just wearing a black fleece, and it's just shed into my sample. So we wear these hilarious looking suits. And yeah, they help with contamination. So sorry for anyone that's squeamish, but this is basically what a regular day looks like for me in terms of dissection. So first, that's step one. So I thaw the fish. I plan my day. So, okay, I'm going to take out fish tomorrow. So instead of eating it, I'm planning my lab experiments. And so this is a saffron cod. So basically, I cut it open in a flow hood, and then all that stuff kind of at the bottom there, that's the stomach lining and more digested parts. And so I will look at that, but I'm also really interested to find what else is in the stomach. So when I open up this fish, I have this beautiful snapshot. It's beautiful to me. I have this lovely snapshot of the food web, which is right there. So basically those 4 fish, they're kind of in different stages of being digested, but those are capelin. And then below that, there's a little shrimp and then a little isopod, which is more of a benthic organism. So it's really great to see that. And so what I do is I not only take the stomach contents and more digested guts of that fish, but I also individually take the stomachs of those fish and put them into separate beakers. So it's quite the process. And so then what I do is, now that I have my beakers with different stomachs of different fish, I then add a very strong chemical base to it that basically turns all the organic material into goop, like it completely dissolves it. And then when it turns to goop, I use a vacuum pump, and there's a filter paper, and so you're basically pumping it or vacuuming it through this filter paper, and so what's left, you don't have any of that goop or anything. What's left is those microplastics. And then we take the the filter, and we look at that under the microscope. And so then we're able to count if there are any microplastics in that individual fish, if there are any, and what types of plastics. So what we do is we go through quality control. So we look under the microscope, you think, okay, I think that this piece is a plastic and this piece is a plastic and this is. And then what we do is we give it to our lab technician, Anahita, who works this very fancy, very expensive machine called an FTIR, which stands for Fourier transform infrared spectroscopy. And this type of machine is actually what's used in crime labs to be able to match a particle to a crime scene, because it tells us exactly what that particle is made out of. And so why we use it is because we want to know if what I've spotted under the microscope is in fact a microplastic, and what type of microplastic it is. And so unfortunately, since I just started processing all of my fish, I don't have any data for you. But these are the pails of beluga stomachs. But what I can tell you is that you have to stay tuned. And we are finding other people's projects. We're finding some really interesting things. And probably next year I'll have some really interesting data. In the meantime, while I'm working on this and probably going back to the Arctic this coming summer, fingers crossed, I think it's really important when you're talking about microplastics research, and while we're in the lab and it's seeming kind of tedious, to continue talking about solutions, because everyone in this room is connected to plastic pollution. We all use plastic every single day, and we can easily turn the tide on plastic, but it's going to take some change of habits. So if anyone attended the event last week, I'm sure some of this might be a bit of a review for you, but the first thing to do is refuse single-use plastics, and it becomes easier and easier. So that's things like your plastic bag and your plastic straw and your Tim Hortons coffee cup, and basically anything you use just once and throw away. And then choose products with minimal to no packaging. So we're really lucky to live in Vancouver, where there's lots of really great stores that you can get things with no packaging, or refill stores. And try to go back to when we were younger and we learned the 3 R's, which are reduce, reuse, recycle. But we tend to really focus on the last one for some reason, which is recycling. But it's really important, I would say, to focus on the first two, which are reduce the amount of things that you are buying that are plastic and using that are plastic. And if you do have those things, try to reuse them. And then if you can't do the first two, then go to recycling, which is also incredibly important and keeps that plastic out of the oceans. And then when you think about your clothing, try to opt for materials that are natural, so cotton and wool and hemp and even bamboo, so that when you're washing your clothes, you are not contributing to that outflow of microfibers. And try to, if you really want to be more radical, you can write letters to companies that you think should reduce their plastic footprint. And of course, participate in a shoreline cleanup. So the Great Canadian Shoreline Cleanup has really awesome resources online where you can really easily start a shoreline cleanup in your community. It doesn't need to be on a shoreline. It can be in a schoolyard and things like that. And yeah, it's a great way to get outside as well. So I actually started to try to go plastic free with my roommate, and we're finding it fairly easy. There are some things that are difficult to do, but I tried to do this last year, and I did it all throughout January, and I didn't buy anything that was plastic, and so now I'm doing it again this year, and I'm finding it way easier now that I live in Vancouver to do this, because we have stores like the Soap Dispensary and soon Nata Grocery, and so you can get things filled up there, and so you're not throwing that plastic away, which is really great. And there's a lot of really great businesses that are in Vancouver, like bakeries, that will allow you to bring your own bag and put it in. And then if something breaks, just try to find things that will last. So less cheap plastic things that will really last you, that are steel or wood and things like that. And then most importantly, keep attending events like these, because it really means a lot to researchers like myself when we see so many people coming out to these events and caring about what we're researching and caring about the oceans and interested in topics like this, even if they're, very detailed and very specific. And it's important to kind of keep yourself educated so that when you're teaching other people about the topic, you're giving them the right information. And so that is basically my presentation. So if anyone is interested, a lot of my trying to live zero waste and practice what I preach stuff is on my Instagram. And then I also have my Twitter as well, which is more me tweeting scientific things if you're interested in that. And then, yeah, thanks to our partners, the Tuktoyaktuk Hunters and Trappers Committee and Fisheries Joint Management Committee and all of our funders and things like that. So, yeah. Questions? Questions?
Can you repeat the questions they asked?
Yeah. Okay. I have to repeat the questions that everyone asks into the microphone. Oh, we have a separate microphone. Perfect. Yes.
Thank you. It was really interesting. I have a question about the methods that you're using for digesting the samples and so on. Is there a sort of a standardized method used to start quantifying and categorizing also plastics so that the data that not only you are gathering, but maybe other researchers across the world are more, it's more representative, more relevant?
Yeah.
So we can make better decisions.
That's a really good question, and that's something that we deal with almost every day in the lab, is trying to standardize these protocols, because microplastic research is, in terms of the research world, it's incredibly new. And so what I'm doing is, I think what's happening a lot right now is there are standard protocols, but everyone is kind of adapting the protocols a little bit to match what they're digesting. So what I've found is that a protocol for sediment, trying to extract those microplastics, is completely different than fish, because you might have to do a density separation, you don't need to digest the organic material and things like that. So that's basically where we're at right now, is we're working, there is no standard protocol that everyone in the world follows. We're basically on the brink of creating those protocols. So it's pretty exciting. It does add more work to our plate because we're developing our own methods, but I feel like we have learned quite a lot within the past few years. Like, we've learned that acids, so if you're digesting a fish gut with a very strong acid, what happens is that acid can take away the color of certain microplastics and break it apart into smaller pieces. So then you're kind of miscounting, and you're saying, oh, there's 20 microplastic particles versus 1, because you've kind of broken that apart. And so what I use is KOH, which is potassium hydroxide. Yeah. And it's been found that it doesn't really affect the characteristics of plastics.
And just lastly, the intersectionality of your studies in terms of sustainability and other efforts that are aimed at the same idea of conservation and protection of not only the ocean, but all the resources. How do you see that playing in your research? I know that you're starting, but would like to see how would you take this into that intersectionality?
Like in terms of policy and bringing it to certain...
Into policy and other efforts that are aimed at, protecting the ocean and the species and so on and so forth.
Yeah, and I think that that's really important especially where wastewater comes in, because there's a lot of potential for policy there. We're just learning how those microfibers might be, basically exiting people's laundry machines and entering the ocean. So when we find out this data, there's a lot of opportunity there for us to contribute to creating policy. Does that include people in their own homes putting a special filter on their washing machine? Perhaps. Does that include better infrastructure in wastewater? Perhaps. So that's kind of where I see it. And, even with my project, when I was there, I noticed that the community did have local waste management issues as well. So I was able to kind of sample around those areas as well, because they don't have that infrastructure, much like developing countries. So if I'm able to find that there are very, very high concentration of plastic pieces in those areas, I can bring that data forward to the community, and maybe it'll help them, you know, inform them a bit more. I hope that answered your question. Yeah.
I had a question regarding clothing materials.
Yeah.
Because a lot of clothing manufacturers are now starting to use, say, like recycled plastics and other kind of post-consumer waste.
Mhm.
So with that being said, especially to do with in the laundry machine, microfibers coming out of that, I know we're trying to help, but is that also now creating another problem on top of that?
Yeah, it's really tough because that seemed like such a great solution and such a great way to recycle plastics, because plastic is made of oil. It's not an infinite resource. We want to try to recycle these things. And I think at the time when that solution was made, the whole field of microfibers was barely being studied. And now all of a sudden we're like, uh-oh, maybe that's not a great idea. So personally, I would choose something that's made of a natural material versus something that is recycled plastic, because even though you are wearing recycled plastic, it will enter the environment, which is what we want to limit as much as possible. That's a really good question. Anyone else?
I was just wondering, other than the really strong tie between the people and the food source, if there's any other rationale for choosing the Arctic.
That is a very good question. So the Arctic is less studied in terms of microplastic pollution, especially the Western Canadian Arctic. So there have been studies done more so around Greenland and the Eastern Arctic, but where I'm studying and where Lauren is studying, which is the Western Canadian Arctic, it's kind of a big unknown. So that's another reason why we're looking at that area. It's a good question. Anyone else with the microphone?
Yeah, I got a question here. I apologize for getting here a little late, and you may have covered this already, but when I first came in here, you mentioned like 5, maybe 6 countries responsible for the majority of plastics and garbage in our waters. Has any of these countries accepted any type of responsibility where they're offering funds or any type of solutions to this, since they are the source countries of where the majority of this plastic's coming from?
Another good question. I would say it's tough since they are a developing nation. That priority might be lower on their to-do list. And again, they don't have the infrastructure, and plastic is cheap. And so these are countries maybe with not a lot of money, and so it ends up going in, they use plastic. It's really easy. It's cheap to use. It keeps their food or their water fresh, and then they dispose of it. I'm not aware of any of these countries contributing specifically. I'm not a complete expert in global marine debris, but I would say that now that microplastics are on the radar at a global scale, they are more aware of it. Sorry, I can't answer that any better. The countries they're all actually part of Asia, so Asia really struggles with waste management. So I believe it's Vietnam, Indonesia, China, Thailand, and I can't remember the other one. I have it written down. Philippines. Yeah. Yeah.
Well, I think that regarding that question, I think it's more complex than just having developing countries producing plastic.
Yeah.
Because developed countries are the ones that are the number one consumer of everything.
Yeah, exactly.
So there's a relationship there that we should always look at.
Yeah, it's no.
The responsibility of, like you said it yourself, it's all of us, right?
Mm-hmm.
And I was just thinking, maybe it's too crazy, but wouldn't it be great that anybody bringing new products would be responsible for looking at the entire life cycle of that product and how that affects not only humans but the environment?
Yeah, that's a really good thing to talk about companies being responsible for that product that they're producing from start to finish, and not just letting it go off to consumers in the world and then putting the responsibility on us. We are responsible, but so are these companies that are choosing these products. And you're right about we certainly can't blame developing countries for releasing marine debris into the ocean, because we are using plastic at such an alarming rate, and we get all of these items manufactured in most of these countries. So yeah, we're definitely not, we're guilty. Yeah, in terms of sewage. Mm-hmm. Yeah, we have a lot of work to do.
Yeah. Hi.
Hi.
Thank you for the talk. It's been great. I know you have preliminary results, or you don't have them yet, but I'm curious to know, you've mentioned that the microplastics and microbeads and whatnot, they bioaccumulate. In that case, are they very persistent? And if that's the case, do they get biotransformed as they move up the food chain or down? And does that cause sublethal or lethal effects? Do you know of that yet, or?
I can definitely speak to that. I don't know if I'd be able to provide like a really definite answer, but what I would say is that there's evidence that it does transfer through the food chain and then basically get pooped out. That's what we know so far. But that's kind of the next big thing, is figuring out how long does that plastic stay in the system of certain animals, because it can't be digested, so generally they just get rid of it. Either, mussels might spit them out or seals might poop them out. But what we're wondering, and what some researchers are more concerned about, is that it's been found that plastics actually pollutants in the ocean can kind of attach themselves to plastics, because a lot of pollutants are oil-based and hydrophobic, so they'll attach themselves to something that basically isn't water. And so there's a lot of researchers looking at, okay, if a fish eats a piece of plastic that might have that persistent organic pollutant on it, the pollutant on it is probably more harmful to the animal than the actual plastic itself. So that's kind of a whole other level of concern of the plastic versus what might be attached to the plastic. But in terms of bioaccumulation, I would say that a simple answer is we're not finding that plastic, like these tiny, tiny microplastics, are just staying in the gut of certain animals, other than the albatross photo that I showed you, where those are larger pieces of plastic that they definitely cannot expel in any type of way, and it's filling up their stomach. But the reason that those species die is because they're not getting any nutrition from it, so they just are so full, they think that they're full, so they basically starve to death, or a piece is very sharp and it goes through one of their organs and things like that. Yeah. This guy at the front, he's keen.
Sorry. I think that's a very good question, and they just need a microphone. That was a very interesting question about bioaccumulation, and I was just thinking to ask you if you know if anybody has done any studies regarding migration of the plastics that, a plastic is made of different types of compounds. Mm-hmm. So if there's any migration because of the acid of the stomach in different species, or even in being in the water for a certain amount of time, light, pH, whatever. If there's been studies around, that sort of shows if there's any migration of these chemicals mm-hmm. into the seawater, or if it's in the stomach of animals, if the acid of the stomach or enzymes, digestive enzymes, is there any migration?
Yeah, so you're asking basically if additives, like chemical additives from plastic, are potentially leaching into sediment, water, animal guts. Yeah, and that's another great question, and that's actually our academic supervisor. She's actually just released a paper about that, and she found that there are some things being leached out, and it's hard to know if it's leaching out from the plastic itself or something that, again, was attached to the plastic. But there are certain plastics that are more harmful than others. So that's one thing I've learned a lot through my research is there are so many different types of plastic, and things like PVC, they have certain additives that are more toxic than other types of plastic. Or when we talk about BPA, so endocrine disruptors like that, yeah, and again, that's why we're concerned about these tiny, tiny pieces, because even though they're really tiny, they're still a plastic, and there is that potential for leaching.
Can you tell us a little more about the work that is done with MEC or Arcteryx, because they're making so many products with, for example, plastic and Gore-Tex? So how would you work with them to make it better?
Okay, so that one isn't my project, but I don't know if you can speak to it or if Anya's here or anything. But from my understanding, MEC and Arcteryx, they've donated different little pieces of clothing for us to test, put through the washing machine, like specialized washing machines and things like that, and then figure out, depending on what type of fabric it is, how many pieces of fibers shed off of different types of fabrics. And obviously they're not just donating fabric to us, they're providing us money for like funding for our research. So, and that is incredibly important because we can run our lab that way, and it's very expensive to run a research lab. So they're, from my understanding, I haven't worked directly with them, but they've been really, really excellent to work with in terms of our research and providing us all the information and materials that we need. And they're really keen on helping us to maybe develop solutions as well.
Thank you.
So I know you're just looking at fish right now, it seems, but you mentioned mussels, possibly taking them in through filter feeding. So I was wondering if you know whether even small invertebrates and filter feeders like that are also taking in small microplastics because they're so tiny that it seems like they could also consume those. And then do you know maybe how pervasive it is even in like the lower trophic levels?
Yes, and yes, they are taking them in. So there's actually a research lab on Vancouver Island that's led by a scientist named Sarah Dudas, and she's looking at lots of different types of shellfish. The last study, I believe, was on mainly oysters, and it's found that oysters really do accumulate those microplastics. I don't know if Julie wants to come up here and talk about her mussels and what she is potentially finding, but it kind of seems like mussels might be able to spit them out better than oysters. So it looks like different species are better than others at saying, okay, this isn't food, I'm going to get rid of it, versus maybe an oyster just taking everything in, because they are filter feeders. So yeah, that's a really good question. And one thing that is kind of on our radar in terms of further research is looking at benthic environments. So basically when I do my fish dissection and I find that little isopod that's more in the benthic area, I am keeping it. I'm not just throwing it out because I want to keep it for future research because we want to look at those benthic environments. So yeah, that's a really great question. Any other questions?
I'm curious about your relationship with the community in the Northwest Territories, and if they're still involved with your research and future plans with them.
Yeah, so right now we are looking, I definitely speak to different people in the community, especially Chiquita, who is living there right now, but we are trying to get some funding and some people organized to maybe expand the ACARVIC program, which is that youth and science program, connecting youth with science, to Tuk. So that's a hope for us. And we have continued to have this partnership it's called the Beluga monitoring program. So it's kind of between DFO and the community, and then we're a part of that as well. So it's kind of this consistent partnership. We're not like get our research and then we're out. We're kind of maintaining this this really good relationship with the community. That's a great question.
I was wondering if you have a method for distinguishing between plastic that's ingested directly versus like accumulated through predation, and just so you can understand like how the plastic is entering the food chain, like at what level is it entering the food chain?
Can you repeat your question? Half of it, I was just trying to find you in the crowd.
Sorry. Do you have a method for distinguishing between plastic that's ingested directly versus plastic that's accumulated through
Right.
predation?
Right. I would say no. We don't have a method for that. I'm just going to give it to you straight. We don't have a method for being able to tell if that plastic has come from a certain fish versus that, let's say I'm looking at the beluga and I find a plastic. I don't know whether that plastic has come from a fish that they ate versus the beluga eating that piece of plastic. The only information that might be able to, anything that could provide me that more information would be the FTIR machine, which would just tell me what type of plastic it is. But again, that could potentially tell me the source. Like if it's polyester microfiber, I know, okay, maybe this is from laundry, but it doesn't tell me where that beluga ingested it or anything like that. Yeah, that's a very difficult thing to know. And that's why when I do my dissections and then I digest it, I'm not kind of keeping it all together and digesting it all together, because I want to individually digest each of those fish so that if I find a microplastic, I know exactly what species it was in.
I had a quick question regarding the Tuk community. I guess maybe two questions. How did you find their waste management practices, and how pervasive are plastics in their daily life? And how receptive are they to the work you're doing, or did you have a chance to dialogue with them about plastics and containment or lack thereof, and how that will possibly affect the food chain in their community?
Yeah, so that's a really great question. So I would say in terms of the different things that they're concerned about anything that threatens their food source, so any type of emerging contaminant, which includes microplastics. And when I talked to people in the community about the research I was doing, they were definitely very receptive and interested in what I was doing and keen to hear about my research. I would say that they struggle with a lot of other challenges as well. So it's not just, they're completely concerned about microplastics and that's everything. They're really struggling with erosion right now in their community, and the amount of that the permafrost is melting. Some people's houses are basically falling into the ocean, or sheds and things like that. So it's not just microplastics that they're really concerned about. They're concerned about a lot of things in their community. And in terms of their own waste management issues, I know that they are improving it, because right now, I'm not sure how familiar everyone is with Tuk, but Tuk just got a permanent road. So generally they had a seasonal ice road that they had to go to their community, and then when there was no ice road, you'd have to fly in and out. And now they have this permanent road that people can travel from Inuvik to Tuktoyaktuk back and forth. And so they have a lot more people coming to Tuk. And so that means more waste. But they also are, I've chatted with people that are they want to beautify their community more, and they want to kind of move the dump to a different location. Because right now, it's not in a great area. People can see it, but also it's very close to the ocean, and so that is a problem that does create that local source of microplastics. So it's not just, potentially microplastics flowing from other areas through the ocean currents that could be polluting their waters. It's their own waste themselves. But it is a lot harder for them. They don't have the same refill stores and things like that we do. They try to use everything that they have, but it can be difficult, especially when you need more of that packaging to keep your food more fresh, because it's traveling a very long distance to get to you if you're buying it from the store. Long-winded and complex answer.
This is a bit more of a general question about microplastics and plastics in general. said journal twice. Can you tell how old a piece of microplastic is? Is there a way to age it?
Not that I know of. Yeah, I don't believe there's any like carbon dating type things for plastic, but if you find a microplastic or macroplastic and it's very, very brittle and the color's more faded, it's likely that it's been in the ocean or on the coast in the environment for a lot longer than something that is less brittle. That's about all I can give you.
Hi, I just want to ask about microplastics in laundry. Like you were talking about maybe having a filter. Like, is that a thing that's kind of coming up? And I've also heard that Patagonia sells like these bags that you put your laundry into. Do you know how effective they are?
Yeah, guppy bags. I've heard of those. I am not sure. Again, I'm not a big laundry expert, but they are... What? I do my laundry. These clothes are clean. I mean, in terms of research. My mom still does my laundry. She's probably watching this right now. Yeah, so Patagonia does have these bags that you can put certain garments in called guppy bags. I think that they are quite effective in keeping those microplastics contained and not going out into the water. And there are these catchment systems. I think traditionally people with like septic systems have used them to not gunk up their septic, but now we're finding that they're really effective in filtering out microplastics. Obviously the downside is that there hasn't been a lot of innovation in terms of that until now. And so you have to empty it all the time, which I guess isn't that big of a deal because we empty our lint trap out. I wouldn't know, I don't do my laundry. But so I would say that these new ways of still being able to wear our fleece and wash it, they are, like companies like Patagonia are working on it, and we're working with them. Got a question all the way over here.
Thank you very much. Hi, guys. This is a question about microplastics that are existent in the ocean up there. Have you noticed, like, did you guys check how much is in there in comparison with other places? And also another question, I've heard that microfibers can be found in salt. Do you know anything about that?
Yeah, I've heard of being found in sea salt. So basically, if you're taking mass amounts of seawater, it makes sense that you would probably find microplastics in that sea salt. So that's definitely a thing. I wouldn't say that it's very, like, extremely pervasive in sea salt. Like, I would still probably go out and buy sea salt, maybe. I wouldn't be worried that I was shaking plastic all over my meal, but yes, that is definitely a thing. In terms of Arctic, microplastics in the Arctic compared to other areas. So again, it's totally different. The Arctic doesn't have the same concentration of microplastics that we know of, like if we were to look at the North Pacific Ocean gyre, where it's very high concentration. But we do know that plastic is there. We know that, especially in the eastern Arctic, they were finding approximately 1 microplastic per meter cubed, I believe, which doesn't seem like that much, but that tells us that microplastics are there too. And in comparison to the BC coast, I think we were coming up with numbers. This was some Oceanwise research that it was about 25,000 plastic particles per cubic meter squared. So that kind of gives you a bit of comparison that, yes, the Arctic does not have the same concentrations as maybe coastal areas around BC do, but what we're finding is that these microplastics are reaching the ocean, these areas that are very remote. And especially now that the Northwest Passage has opened up with climate change, we're going to have more ships going through there, and those can add to that problem as well.
So if microplastics do not enter the food chain, how long is its lifeline, and what is its final destination in some sense?
The final destination. So basically, if like an animal eats microplastic and then it gets pooped out, and then where does it go?
No, if it doesn't enter the food, does not enter the
If it doesn't, okay. So if it doesn't enter the food chain, but it's still in the ocean? Yeah. Okay, so it depends on the plastic because different plastics have different densities. So that plastic might be very dense and it might sink to the bottom in the sediment and stay in the sediment and maybe stay there for a very long time or get buried, or it might get ingested again by a benthic organism, or the plastic could float on the surface of the water for a very long time and then become what we call biofouled. So bacteria and different things attach itself to that plastic, and then it won't float anymore because it's more dense, and again, it will start sinking or it'll stay kind of suspended. So it's not just on the surface that there's plastics, but it's suspended and it can also sink. And so that's why there is more research going on in terms of sediments, and microplastics have been found in deep sea sediments, and now that makes sense because we know that plastics can become biofouled and change densities and sink to the bottom. Any other questions?
Just wondering, following up on that, do you know anything about the distribution of plastic densities throughout the water column of the ocean?
Oh, it's a fairly broad question. I would say that throughout the water column, most plastics are quite light and tend to stay on the surface. And that's why sometimes with our methods we do density separation. So it's getting late for me, guys. We do density separation. So basically, if we're trying to find plastic in sediment, we might do a density separation because a lot of plastic does float and it'll become lighter. And we might put it in like a hypersaline solution to make it float even better. But I don't know exact numbers for you in terms of distribution, in terms of how many pounds of plastic might be on the surface versus below the surface versus on the seafloor. But that would be a great research paper. Get on that.
Hey, do bacteria degrade plastic, or are there any kinds of bacteria that can?
Ooh, that's a very good question. I would say there might be certain types of bacteria that might degrade what we consider bioplastics, but I am not aware of any breaking edge science that there is some type of bacteria that eats plastic. Yeah, it's hard to stay on top of all the studies, but does that sound right, Microplastics team? I think so. Yeah. We'll look more into that. Anyone else?
Are there any more questions? We have time for maybe one or two.
You're welcome.
Well, I'd like to thank Rhiannon for the amazing talk and the awesome answers to questions, and glad that she does her laundry. And just to thank you again for coming, and to reiterate what Rhiannon said, that it is very important, and we're very happy that you come to events like these so that you can get educated about cutting-edge research, and you know what you're talking about when you try to make decisions about how best to reduce plastics and how to help the environment. So yeah, thanks very much for coming. And then another reminder, at the back there's some leaflets. You can pick up some information about how to volunteer, and as well, Rhiannon mentioned the Great Canadian Shoreline Cleanup, so that's another way to volunteer. You can host a shoreline cleanup yourself if you have a beach that you think needs to be cleaned up, or volunteer for an existing one. So thanks again, and also don't forget the donation box at the back. If you have a spare loonie or two, that would really help us run more programs like this. So thanks very much.